Welcome back. In this lecture, we will address the topic of testing. At the end of this lesson, you will understand the basic principles to structure an experiment and check your hypothesis. You will learn how to design an experiment to test an hypothesis, manage variables and conditions, and assess the validity of the experiment. Let's start with the definition of your variables. In your study, you have an hypothesis that you want to test. To do so, you have to design an experiment that must follow some rules to provide scientifically valid results. First, your experiment must have a dependent variable, that is what you want to observe and measure. Second, the experiment must have at least one independent variable that you will control during the experiment. It's important that in the experimental design it is clear which are the variables that you will manipulate and that are expected to have an observable effect on the dependent variable. Anyway, in an experiment you may have more aspects that you need to manipulate, and this means that you may have multiple independent variables. But even if you have only one, it may have different levels. To explore the effect that each specific level has on the dependent variable, they should be manipulated independently. To do so, you should have different experimental conditions, one for each level of the independent variable. The experimental method requires not only to make a distinction between different conditions, but also to check what happens if you remove or make equal to zero the independent variable. This is defined as the control condition. Now let's talk about the validity of your experiment. How do you know if the results observed are reliable? First, you must be sure that the experimental validity of the study has been respected, and to do so you have to consider different kinds of validity. We can start with the internal validity, which concerns the relationship between the independent and the dependent variable. The internal validity is high if the variations on the dependent variable are caused by the manipulations you are performing on the independent variables, and not by other factors that you are not controlling. Another important aspect is the external validity, which is focused on the possible extension of your results to another situation, usually larger. When you are dealing with human factors, it's important to consider how representative is the population of your study, and also how faithful the experimental setup is compared to the real world. The last aspect is called ecological validity, and is the possibility to extend the data collected during the experiment to the natural behavior that participants would have in the real world. For example, you could simplify the task of your study to increase control over the variables. However, by oversimplifying, there is a high risk of obtaining artificial results that do not reflect what really happens outside the lab. And finally, we have statistical validity, which is the probability that the observed effect on the dependent variable are due to chance and not to the controlled variables. As we saw before, when dealing with human participants, it is important to know how to distribute them among the experimental conditions. A poor management of this aspect can easily introduce biases into the experiment, heavily reducing the validity of the data obtained. The way you manage the distribution of participants and conditions defines the study design. Here, one of the main distinctions is between subjects versus within subjects design. In between subject studies, the comparison is made between two or more groups of participants distributed among the experimental conditions of your study. This is useful, for example, if you know that there is a possible learning effect in your conditions and you don't want a person repeating the task more than once, because this will affect their performance and your data. On the other hand, there are some things that you must consider if you choose a between subjects design. When you compare groups of people, you must always check if those groups are balanced. Otherwise, the risk of obtaining false positive or negative results becomes really high. The other structure we introduced is the within subjects design, in which you make a comparison within the same participant. This choice allows to avoid any effect originated by individual differences, because the comparison is always made between the performances of the same person. In this situation, you can consider the control condition as a baseline, because you can use that result to check the main effect of your independent variables by comparing every experimental condition with the control condition, so without the independent variable. Finally, you can have mixed design, where there are between subjects and within subjects variable in the same experiment. In this case, the participants will be divided into different groups defined by the between subjects variable. Then, inside each group, each participant will go through all different conditions determined by the within subjects variable. In conclusion, a solid experimental design is the key for obtaining reliable results. It helps keep things controlled, so you can trust your findings and ensure they actually add value to what you're studying. In the next lesson, you will learn how to design XR environments to support your testing.